Yeah. So in IBM in information server suite, there are some 10 to 11 softwares in total which are available. Like the list is these, which contains the blueprint director, business glossary, information analyzer, data stage, quality stage, fast track, uh, metadata workbench, and so on. So there is a huge list, right? And all of these together will help you do the end-to-end analysis so that you can load the data, understand the source. Uh, I mean, the first step is understanding the source system, clean the data, transform the data using Datastage ETL, and then if the data is loaded into multiple data warehouses, you can pull them and have a glance uh, from Federation Server, which is a virtualization software, data virtualization software. But all these different softwares which are part of information server suite are having the similar kind of architecture uh, which is relevant to the architecture of information server suite. We will try to understand the architecture of information server suite. Uh, During this architecture understanding process, we will use Datastage as an example. So wherever if I need to communicate something, I will be taking examples from Datastage, so it will be easy. And in future, when we are learning Datastage, you can correlate. It will be like a correlation. So in this information server suite architecture, we have four components: client tier, service tier, engine tier, and metadata repository tier. These four components are created in such a way that you we can uh, in the current days we can install it on one server or we can install it on multiple server. So that is the way it has been created. Client tier has been created always in the same way. We can install the client tier on any number of systems, because the client tier is the one from which we will or which will be used to connect uh, from our local to the server, right? So like if you're working for a corporate company, so you will have the server installed on or all the other versions like service tier, engine tier, and metadata repository tier. All the three versions will be installed on some other server, and the client tier will be installed on your machine from where you will be connecting. You will be connecting to the server. So that is how the client is installed. So basically, you will be seeing that administrative client, designer client, director client, all these client versions will be installed. These icons will be coming on your computer, and from there we'll be connecting to the main server. Service tier is the component where we get services, and engine tier is the component where execution happens. So all the job executions, the I mean all the job executions, the connectors, the logging, everything is actually part of the engine tier. So we'll go through them one by one. Now let's look into the service tier component. Service tier, what happens is there are two components in service tier precisely. One is the product-based services, another is the common services. So what IBM has done is looking at, because this suite contains a huge, I mean, some 10 to 11 softwares. All all these 10 to 11 softwares will have a set of services which are reusable. Like when you're connecting to database, when you're connecting to file systems. So all these connectivity mechanisms are nothing but reusables. So if you have a particular method like a one way to connect to say DB2 database, so whatever and however it be, from whichever system or whichever software you're trying to connect, you will be connecting in the same way to that software, to the DB2 database. So that is the reason what they have done is they have kind of brought them together, right? Saying that okay, these are the set of softwares, all these, all these set of softwares will be using the same functions or maybe the same service in the background. So they have brought that together. The if this would not have been done, what would have happened? Suppose you install two softwares or three softwares. All the three softwares will have their own component to connect to DB2 database or any other database own component. Say, so there will be three components to connect to DB2 database, three components to connect to Oracle database, and these components are doing nothing but just the connectivity part, right? So unnecessarily you are having you are increasing the number of services which is in turn going to consume the resources and is slowing down your system. So that is what is the issue with having, I mean, what was the thought process of bringing the services which are utilized by multiple softwares in one section called as common services. Apart from this, every system, every software has a different has their product specific services as well. Like if I take example of say information analyzer. So I told you that when you are trying or when you want to get the information about the source and the column structures. So this is one kind of setup which is available in information analyzer. It will tell you what is the source column names, what is the prescribed length, data type, and what is the actual maximum length contained in each and every column. Now this is something which is only available in information analyzer. You cannot do it in data stage, right? Uh, from Datastage perspective, we have different different other methods, like you have we have different connectivities which are only available for Datastage. Like till now, information analyzer or any other softwares are not that comfortable connecting to cloud-based computing system, because mostly those softwares are available or have this information that these softwares will be used to connect the source, which will be on a normal database. As of now, it's not assumed, or IBM is not considering that these softwares are something which will be used to connect to clouds. Only Datastage has the capability to connect to cloud-based system like Salesforce or AWS or Redshift, etc. Right, so in that case, those connectivity is only available for data stage. So we can say that piece of connectivity is nothing but a product specific service for data stage, right? So similarly, there can be many other components, but what I'm just trying to explain here is the grouping has happened such that those components which are reusable by many other softwares, many other products are clubbed them as common services, and those which are specific to a particular product are clubbed as product specific services. Now when you install any software among these, so the common services, all of those services will get installed. However, only the product specific services for that specific product will get installed. So that even if you are installing multiple softwares, only uh, one set of common services will get installed and not multiple set. Now, so these two are the main component of service tier, but there is one more component which is equally important. This is called as application server, or which this component actually makes this service tier behave as a server. So whenever you try to connect to a server, you need to have an IP address, and there should be some service or some component which should be actually responding to it, right? So there should be something which should be actually responding to it. So for that, that is actually done by the application server. If I try to connect, suppose you're trying to log into your Gmail account, right? And if the Gmail server is not available to accept your request, then you will not be able to obviously log in. So that kind of acknowledgement is being done by the application server in service tier. You will also see that there is another component here on the right hand side, which is engine tier. Now if you look closely, these two look like two different components altogether. These two are two different components. Service tier and the engine tier are two different components altogether, meaning there should be different connectivity to these two different components, service tier and the engine tier. There should be different username and password, or maybe the same username and password, but as you can see, they are two different components. You can install it on two different servers. So then there should be there could be a possibility of having two different credentials, username, password, and all that, right? So how then the question comes up is like, if I want to log in, so every time do I have to log in from the client tier? I will be trying to connect to the service tier and the engine tier both. So the answer is no, not every time. I should say never, because when you're trying to client tier, you'll be connecting only to the service tier, where your application server, based on your credentials, will acknowledge your request. The one-time activity, once Datastage is installed, you get your credentials in a company when you're working. This is a one-time activity where they will come up and you have to do an engine mapping setup in web console. So I will show you in the sessions to come how to do an engine mapping setup in web console. So once you do that, what will happen is when you try to connect from the client tier to service tier using the one set of credentials for application server is in turn going to hit the engine tier with the one-time credentials that you have already stored and verify if it is correct or not, and only if the credentials are correct it will return with a acknowledgement saying that you can connect. Otherwise it will give you some kind of errors like engine mapping is not done or engine credentials are not available, or the username and passwords are wrong. So don't worry, I will show you all those error messages when we are looking at the web console setup. I will show you like if a new user is created, those error messages comes up, right? Uh, so that is about the application server importance. Now let's look at the engine tier. Now this is one of the most important section. The reason is all the execution happens at this part. When you try to execute your job, the execution will happen in the engine tier component. So here you will have the engine information server engine, which will work for data stage, server job, parallel job, and sequencer jobs. So these are the three different types of data stage jobs. It will work for all the three. Here you will have connectors and packs. Packs are add-on features which are available in Datastage. Like there is something called as balance optimization in Datastage. So this is nothing but this is an add-on pack. They sometime back nowadays it's available by default, but in the lower versions like say 9.1 and say 11.0 or 11.1, the Salesforce connectivity or the I should say cloud-based connectivity was not available by default. Those connectivities were available only through add-on pack. So if you are interested that okay I need or some of my source or my target is actually on Salesforce or say AWS or stuff, you will go back and say IBM that okay no I need this connectivity. There is a pack that will be given to you, and once you install that pack you will have connectivity to Salesforce or AWS or whatever the cloud-based system you wanted to connect. So that was coming as pack. In the current version 11.5, all these are coming by default. All the softwares are coming by default and with an increased pack cost. So the cost of our IBM Datastage software has been increased, and with the moment you take that software, all these things will come by default to you. But this is the basic concept of pack. So as and when any new component they create, they won't start launching it or giving it to the client as a base component because of two reasons. First, risk is you are giving a software which you have just created, which has not been may not been thoroughly tested or may not have been tested on a real-time data. So that could help or that could create a situations of the issues coming up in the client system, right? The vendors who are the companies who are going to buy Datastage, so there may be issues in the data. Another thing is the reputation. If there's any issue, that the data corruption, anything happens, the reputation will go down. So, and the clients will not understand that okay, it's because of this specific pack. They will say that something is wrong with Datastage. Datastage is not good enough a software to take and go ahead. So they will simply come up and say that okay, let's not use Datastage, let's use some other ETL tool. But when these things are coming as pack components or components from a pack perspective, IBM clearly says that okay, if an issue comes up, you remove these pack and there'll be no issue. But there can be some issue while you're loading data to so and so, or while you're using these packs. So if suppose you're using Salesforce connectivity, there may be some issues because thoroughly for all the different kinds of data available in the world, this connectivity or this pack has not been tested yet. So it makes clear sense. Connectors are, so that is about the pack. Connectors are an interface. So when I'm from data stage, when I'm trying to connect to a database, the connectivity of database happens from the service tier. But the placeholder for the connection information is actually something which is available in the engine tier. Meaning, when I'm trying from an engine tier to connect to the to say a database, a DB2 database, or any database, right? So I need some certain informations like the user, the IP address or the schema information, then the username, password, then what you're trying to do, you're trying to select the statement or you're trying to insert, update or delete, right? And there are certain set of tuning and all those stuff that is available. Though the tuning is by default has been tuned by IBM and we don't tend to tune it, but still those options are available. So a huge amount of options are available using which we can go ahead and modify the connectivity properties. These options are actually accepted as a connector stage in Datastage. So it's like a front end basically, I should say. So it's like a front end where you will punch in the details and those details will be stored, and once executed using these details, the services will be invoked in the service tier and those information will be passed as parameters, and the corresponding service tier, the services will be executed and implemented. So that is where the connectors are useful, because we need a placeholder to provide information relevant to database connectivities. So that is where the connectors comes into picture. It helps us to provide all those information. Then the quality stage model is also I mean, it's all quality stage and data stage is nothing but in one software. Both of them will be available depending on if we have installed or it's not installed. Okay. Now the service agents like the logging, okay, job monitor, resource tracker, and all these are available in the service tier. Slowly we'll come to know what is job monitor and resource tracker. Logging is something like when you're trying to execute a data stage job. So you want to do a logging each and every step you want to do a logging. Similar kind of logging happens when you try to connect from a client tier to other service tier using application server, right? Then the question comes and uh, yeah, so then the question comes is why we have a logging information in the engine tier and why not in the service tier? Well, the reason for this is when you execute your job, you will get huge amount of logging information like all the job execution, each and every step that will happen, right? And every other each and every minute details will be something that will be logged. If this logging agent is available on the service tier, then there will be constant connectivity between the engine tier and the service tier, wherein the engine tier will keep on pushing the entries for the logging to the logging service or the logging component in the service tier, and that is actually a burden on the network, because as you can see the engine tier and the service tier can be installed on two different computers. So when this is a burden on the system, so what IBM has done is they have moved this part into the logging component of the engine tier. In the engine tier it becomes easy, then the network burden gets off, it is waived off. Yeah, some of the logging which is also done from the service tier, which is minimal, that minimal goes through the network and reaches the engine tier and the logging happens. So this is about the engine tier. This is the fourth component called as metadata repository tier. Now this metadata repository tier is responsible for all the database stuff, database connections and everything. So suppose you're trying to connect or you're trying to execute a data stage job which has a connectivity to a database where you're trying to select the statement. Say you're executing select star from table, and the database is an Oracle database or any database ideally, and you're trying to execute this statement select star from table. Connectivity information, everything has been provided through the connectors. Now what happens is when you execute your job, the engine tier will send the job executables information, the information from the job executables relevant to database connections onto the service tier. Service tier, the common services section where the database connections are available, it will accept your connectivity and provide a connectivity. So it will, using those connections, it will hit the database and provide the connect and check if the connectivity is available or not, if the connection information that we have shared is correct or not. In case the connectivity information is correct, so there is no issue in the connectivity information, what this software, what is going to happen is, so it has opened a port chain, so it has opened a bridge where it has tested the connection. Now it will pass on this bridge to metadata repository and say that, okay, this is the connection, this is the open connection, and this is the statement that you have to execute. Execute the statement, fetch the data, and push it to the engine tier. So then metadata repository will do all this pulling of the data. In case of inserting or updating the data, insert and update of the information. So it will do all this stuff, and then based on the operation that metadata repository is doing, like insertion or updation or whatsoever, or selection, it will respond back to the engine service tier, and from there the response goes back to the engine tier, updating like, okay, this activity is done. So this is how the end-to-end process happens for the metadata repository tier. Now me as a user, so this is about all the different components. If you have any doubt here, uh, let me know. Okay, so let me proceed. Now, me as a user, I am trying to connect from the client tier to the service and the engine tier. So when I'm trying to connect from the client tier to the service tier and the engine tier, all right. So how things will happen? What is the process? So let's talk about that. Now, when you're connecting from the client tier, you can see that there are an arrow connectivity from a client tier to the service tier and from a client tier to the engine tier. So that means from a client tier you can directly connect a service tier and the engine tier both. So how is that possible, or how it happens? Let's look at certain examples for that. So when you're connecting from a client tier, when you're trying to log in from a client tier, you have certain um, you're providing your credentials and you're trying to connect. So at that time the connectivity comes from a client tier to the service tier. Thereafter, right? If when you're trying to and you will get the connections. So that is how you're connecting only from a client tier to the service tier. From a client tier to the engine tier, when you try to execute a data stage job, you connect from a client tier to the engine tier. Directly execution is happening at the engine tier front. So you're connecting from client tier directly to the engine tier and executing your job. If engine tier is interacting like it's trying to fetch data from a database, so then it is going to provide information relevant to connectivity information and goes to from this engine tier to the service tier, asking for the connections, asking for the common services to use those connectivity details and fetch the data or insert the data into the target tables, to the databases. So that is how the connection happens between the engine tier and the service tier. And always there is a metadata repository tier who does this, all the data connections and all. So this is how these all are connected to each other. Now in an ideal situation, right, what happens is, or so how this plan of dividing these components into into individual components has come up. So exactly when IBM actually, not IBM, Datastage was an essential software. So it was a software from Essential. That was the company name. IBM took it over in 2007, 2008, sometime near on that. So before that, it was so when initially Datastage was launched, people did not thought about the humongous amount of data that we will have in future. At that time, what they did is what they had is a client tier and all the three different components into one system. At that time, these softwares were not having these features as well, this much amount of features. So it was possible, it was working fine, but slowly as the need of the company increased, because you see, if you have 10 individuals using Datastage, all those 10 individuals will be connecting to that particular server where Datastage is installed. If that server is addressing the request of 10 users, then all the 10 users request should be available on that particular server. And if more load is coming to the server, the server capability to execute job, and if the more data is coming or the more data is coming to get processed, again the server capability to execute jobs will slow down. So because of all these things, the performance will go down, and that is where the issue started coming up, where business started thinking, okay, or the essential team started thinking how to go ahead or go around with that. So initially, so slowly they started dividing the component, clubbing them together into different components so that the performance can be enhanced. And they came up with this approach of having a service tier, engine tier, and a repository tier on. And then the next set of section was we installing them on two different systems, service tier on one and engine tier on another. Now today, slowly with the enhancement and looking at the issues we are getting with the performance and all, today we can install service tier on multiple computers and engine tier on multiple computers. And with the passage of, I mean, with the continuous passing of time and issues that we face, the system has been enhanced so that the topology, grid topology, can be actually used to uh, to be available in to provide engine tier on multiple servers, and these multiple servers could be similar to Hadoop system. So that Datastage is actually also supporting Hadoop architecture. So we will be looking into that in time to come, right? So this is about the architecture. There is one more architecture which is slightly, I mean, which is Datastage architecture, and where I want to explain, like, there are two engines in Datastage, parallel engine and the server engine, precisely because of the two components, parallel job and server job of Datastage. So in the beginning, when Datastage started coming up and we started using Datastage, maybe I practically used the server versions. At that time, the parallel versions are not that use. I mean, it was not that much usable. The companies were not using the parallel versions. It may be in 2007 or before, but the server versions are more widely used. Now, server versions are something are the Datastage jobs which were used in sequential mode, so they had their own properties, but there was a specific server for executing the server version which was called a server engine. And and slowly when the upgrade happened, so there's another version which came into picture for executing the parallel job, which was called as parallel engine. So they created parallel job, server job. Server job was executed by server engine, parallel job was executed by parallel engine. Right. There is a shared repository which is nothing but stored in database DB2. So when you install Datastage, by default the software DB2 will get installed. This is the place where all the information relevant to your credentials, relevant to your repositories, relevant to your logging, everything will be stored in DB2 database in an XMeta schema. So the schema name is defaulted. I mean, it's set. We cannot change the schema name. So that will be installed in XMeta schema. All these things will be keep punching in, and the credentials are only available from Datastage, so you cannot access it outside Datastage. That is about this. Then also you will get three different softwares. I mean, nowadays you are getting slightly more softwares when Datastage client gets installed on your computer, like web console and all, right? And currently the availability of these software is completely dependent on the administrator, because the installation happens through Citrix mostly now. In a project or in a company, mostly the installation will happen on the server, and we will get a Citrix credentials from where you will be able to see all these icons and you will be able to connect to those softwares. So in Citrix, what are the different softwares will be visible is something that is dependent on the Citrix administrator. So based on that, they will either provide you the designer client, director client, and maybe the web console, and may not provide the administrator client services. However, the virtual machine that we'll be sharing will have all the different softwares, I mean all the different components relevant to Datastage, which will be used for implementation. So you have full admin rights on that. You can go ahead and do all those admin activities, whatever we will be discussing in this training. So this is about the architecture. Now let us understand what are the three different types of Datastage job that we have been talking from, say server job, parallel job, and sequencer job, and how they vary. To be honest, this is very important. We'll be covering parallel job and sequencer job only, not the server job. You will come to know in some time what is the difference and why we are going to only cover parallel job and server sequencer job. So let me bring up a notepad and let's discuss the pros and cons of the different jobs. In the meantime, in case you have any doubts, do let me know. Okay, so server jobs. So these are the three different components: server job, sequencer job, and parallel jobs. So in the server job, right, first thing is the jobs are created in so the three different jobs have three different colorings. Meaning, when you see data stage, I will show you this. Server jobs are in yellow color. Okay, parallel jobs are in red color, and the icons and all. So parallel jobs are in red color, and the sequencer jobs are in green color. So first thing is color. Based on this color information, color itself, you will understand like which job is these jobs are of parallel job or sequencer job or a server job. So color coding has already been done. Server jobs are executed in sequential mode. So that is one drawback of having a server job. Executed in sequential mode and by server engine. Second feature of server jobs are the server engine that we have is it has the compiler. So the compiler name is basic compiler. Basically, basic compiler is the one which executes the server job. So I can say executed by basic compiler. Now basic compiler is the compilation engine. Okay. So these are the two stuffs. We have limited number of stages. If I will show you in Datastage, we have limited number of stages available in the server job as compared to the parallel job. So that this number of stages available in the server job is less, limited, very less. 10, I think 7 to 8 or 10. That's all. However, in parallel job you have 30 to 40 stages. So that's the difference. Any requirement that you want to implement in a server job, it's little tricky, little difficult, because you do not have sufficient stages to implement all the requirement that you could possibly get. But in parallel job, you have so many stages that any requirement you get, you do not have to worry about it. You can implement it from a parallel job. So that is the beauty. So a server job being executed in the sequential mode, the performance is slow. Because the server job is executed in the sequential mode, we have a very slow performance in sequential server job execution. And because of that, the performance get hit, the time taken get increased, and uh, and it's not executing in parallel. So what I'm trying to say here is uh, it only uses one server, one computer to execute everything. So the performance, everything is get hit. Comparatively in the parallel job, it executes in parallel. Okay, and parallel engine comes into picture. Okay, orchestrate compiler. So I'm just trying to put the difference between these two. Orchestrate compiler is the compiler that is used in the parallel job, but not and in server job we have basic compiler. Now one thing that you will notice is so the question comes is, okay, there are certain stages in parallel job, certain stages in sequencer job, server job. So can I call a certain stage of a server job from a parallel job, or can I use some of the stages available in the server job from a parallel job and vice versa? No, you cannot. You cannot do this part. Okay, so that is something that we are not allowed to. Then there are two more components that is available, like server routines and parallel routines. Again, server routines can only be invoked by server job. Why server routines are available? So server routines are available because in server job there was no flexibility of implementing all different requirements that a company could possibly have. So then IBM has created So then Essential has created an option of creating routines, which you can write in C++ coding. So if at all such certain requirements comes up, where you want to implement some input, some information, some coding, and you do not have sufficient stages available, you can go back and write those coding in routines and get them implemented. So that is where server routines comes into picture. Datastage parallel job also have a component called as parallel routine, but parallel routines are not used widely. Reason: there is no such requirement which could not be implemented from the stages available in the parallel job. So in that case, you won't get a necessity or you won't get a use to execute or create a parallel routines. Additionally, I will show you in the classes that parallel routines you cannot execute. I mean, you cannot create a parallel routine straightforward as you can create a server routine. So in server routine, you can write your C++ code, but in parallel routine, you have to invoke these server routines. Parallel routines just an interface to create the server routines executed in parallel. That is only the difference. Parallel routine is nothing like you can create a parallel C++ coding routine. No, it's just an interface which you will be using to invoke the server routines only. So at the end, in the background, server routines are only the one which will get executed, but through a parallel interface. So server routines will be executed through a basic compiler of the server engine, server jobs, and parallel routines will get executed through the parallel component of the parallel or how exactly the way the parallel job gets executed in parallel. So the compiler version gets changed and all that thing happens here. Okay, next is the sequencer job. Now here in parallel job we have a great performance because the job gets executed in parallel, and there are other concepts like partitioning and pipelining which comes into picture in parallel job, which enhances the performance. With the enhancement of performance, this is most widely used. We have huge amount of stages available in parallel job which are not available in server job, because of which the execution time or the job creation becomes easy for a developer. So that is about the parallel job. Let's look at the server sequencer job. Now sequencer job is again, it executes in sequential mode. Okay, it executes in sequential mode, executed by server engine again, and basic compiler. So these three are the components which is most widely, which is most important. The stages that we have in sequencer job are different from server and parallel job. Like if you see server job and parallel job, the stages will be like in both of them you will find stages like join, right, filter, funnel, transformer, etc. Data DB2 connections and all. In sequencer job you won't find these stages. So the stages are not at all this. The stages are something like job activity, right? Execute stage where you will be executing certain Unix command. Routine activity where you will be executing certain routines. File watcher, which will or file activity, which is actually used to see if the files are available or not, which behaves as mostly as file watcher. So these are some of the stages that is available in sequencer. So you will see that the stages in sequencer jobs and parallel server jobs are completely different because the functionality varies. Where in server and parallel job, the intention was to create the jobs and implement a business requirement. The sequencer job is most precisely looking for creating jobs which can execute server or parallel or a sequencer job. So the sequencer job acts as a control structure, okay, a controlling body which controls the way your Datastage job gets executed, whether it be a server job, parallel job, or a sequencer job. It simply controls the way the different jobs get executed. So if you have a dependency, say you have created two different parallel jobs, you want your business says that only when the first job gets completed, the second job should get executed. So this dependency you can create in sequencer job, right? If you have created a server job and a parallel job and you want to create a dependency between these two different jobs, this dependency you can create in sequencer job. So sequencer job can trigger a server job and a parallel job irrespective of the engine that is involved in. It doesn't matter. Engine doesn't matter. So sequencer job is mostly acting as a control structure. So it's like a control framework where you will put your requirement and it will go ahead and execute it. What happens when you're having a sequencer job and a parallel job in your data stage job in a sequencer? So sequencer and then a parallel job. What happens? So when you have a sequencer job and a parallel job and you're executing it through a sequencers, so sorry, server job and a parallel job and you're executing it through the sequencer, what happens is when the execution happens for the server job, the sequencer job sends the control of the server job execution to the basic compiler of the or the server engine. And once the execution of that happens completely and the control comes back to the server engines, the sequencer job, this sequencer job looks that okay, it has been completed, so then it will, and the next job is a parallel job, so then the next control it will pass it on to the orchestrate compiler, which is nothing but the parallel job compiler. So depending on the job low execution type, the compiler changes, and on the fly the sequencer job is able to make these changes. Okay, so this is about the three different types of data stage jobs. uh, Yeah, let's have a look. These are the screenshots of the administrator, designer, and director. Let's have a look at the component that is mentioned in the slide so that we don't miss anything. Uh, one more, I mean, along with all these, so you might, I was expecting this as a question, but it did not come up. So when I was saying like in routines, you can write C++ coding. So how the C++ coding is available? These C++ codings are available because Datastage has this flexibility to add in the C++ components. Meaning, when you install Datastage, one prerequisite is you have to install the C++ or Visual C++, I should say. You have to install the Visual C++ in Datastage. Only when Visual C++ is installed, Datastage will be able to uh, access the C++ components. And the transformers that we have in Datastage, whether it be for a server job or a parallel job, are actually in the background coded in C++, and that gives the transformers the beauty to execute uh, any kind of requirement. So you will any kind of transformations you need, any kind of filter criteria you need, type conversions you need, everything is available in transformer because in the background it is using all the C++ component. So whenever your data stage job has a transformer, so you're creating a job without a transformer, it will be compiled by orchestrate engine. But the moment you add in transformer, the C++ compiler will also come in the picture because the transformer components are compiled by C++ compiler. So then both the orchestrate and C++ compiler will come into picture and collectively will compile the that specific job. So parallel job are executed by parallel engine. Pipelining and partitioning are something that we have already discussed. It's compiled by OSH compiler, which is orchestrated scripting language. And when C++ comes into picture, it's compiled by both the component. It has executable C++ class instances, yes, because you have to install a Visual C++ mandatory with any version of Datastage, and runtime monitoring in Datastage Director. Now this runtime monitoring is actually available for any kind of Datastage job, so there's no point on talking on this. This is a by default feature of Datastage Director. Job sequencers, it's like a control structure which is like a master server that kicks off all the jobs. So it controls the where the job gets executed. Uh, it is executed by the server engine. It can kick off both server or parallel jobs. So I'm just going to the PPT to ensure that we did not miss any of the points that were supposed to be discussed uh, in correlation with these three different types of jobs. Next is server job, which is executed by Datastage server engine, compiled by basic compiler, and again the runtime monitoring is happening by Datastage Director. Okay, any doubt till now? I mean, we have discussed quite a good amount of content today. Architecture of information server suite and the different types of Datastage job. These two are very, very important. Architecture will help us understand how, I mean, when we are trying to execute things, what actually is happening in the background. So if you have any doubt anywhere, do let me know. No questions, no doubt?
Not from my side, Anshul.
Okay. Okay. So if there is no queries, then let's stop today. We'll meet tomorrow at 6 and we'll proceed from there.